Today we are pleased to introduce David M. Michelson as part of the Wisconsin History Museum's History Sandwich-In Lecture Series. The opinions expressed today are those of the presenter and are not necessarily those of the Wisconsin Historical Society or the museum's employees. David M. Michelson was a professor in the Department of Geology and Geophysics at the University of Wisconsin-Madison for over 30 years. In his time at the UW, he taught, among other things, glacial geology, geomorphology, and the geology of the national parks. His interests are in modern glacial processes, glacial deposits and landscapes in the Midwest, and coastal processes along the Great Lakes. Michelson and his students have worked on the genesis of glacial deposits around the globe, from Argentina and Tibet to the states of Alaska and Wisconsin. And he is also the author of Geology of the Ice Age National Scenic Trail, which is a book available in our museum store. Here to share how southern Wisconsin's glaciated landscape came to be what it is today, please join me in welcoming David M. Michelson.
Thank you. Well, as you've just heard, I'm a glacial geologist, and I'm interested in the glacial landscape of Wisconsin, among other things. And today, I'm going to not talk just about the landscape, but a little about the tools that we use. I'll give you a little historical perspective of what people could see when they were doing mapping 100 years ago compared to what we can see now, and in particular introduce this fairly new remote sensing technique called LIDAR, which is a combination of light and radar that produces really high resolution images of the landscape, and these are drumlins in northeastern Dane County. And you'll see some even more spectacular images as we go along. So let's proceed. First, I think all of you probably know, but just in case, we are in Wisconsin right at the very southern edge of the Laurentide ice sheet, this huge ice sheet that stretched from the Atlantic Ocean to the Pacific Ocean, all the way across well, it was actually sea ice over the Arctic Ocean, but you could have stepped onto the glacier right here outside of Madison and walked all the way across to southern Russia. Across the northern polar area without ever getting off the ice. So it was a huge amount of ice, and we are located just at the very edge of it. This was from the last glaciation. It's called the Wisconsin Glaciation. It's called the Wisconsin Glaciation because the glacial features in Wisconsin are particularly well developed, and also it didn't hurt that T.C. Chamberlain, who was instrumental in naming the Wisconsin Glaciation, was teaching at the University of Wisconsin, so he was probably a little bit biased. So we'll hear a little more about Chamberlain as we go along, but I want to start by, just so you have an image of what it looked like to have the glacier here about 30,000 years ago. You're going to see a little movie now that will show the glacier coming down fairly rapidly about 30,000 years ago, and then staying out pretty much near its outer edge until about 18,000 years ago. And that's when climate warmed, and the glacier really started to fluctuate in its position. So it retreated and advanced, and it retreated and advanced. And that's probably when most of our glacial features in Wisconsin formed. It was pretty late, so from about 18,000 years ago until the glacier left Wisconsin about 10,000 years ago is when most of our landforms like drumlins and so on formed. So watch the movie. 31,000, 30,000, 29,500, and so on. And of course, you know that these are the Madison lakes down here, and sometimes a lake forms out here. That's called Glacial Lake Wisconsin. You'll hear a little more about that as we go along today. And Glacial Lake Baraboo. But you see the glacier staying more or less out near its outer edge. And now, 18,000 years ago, now things start to happen quickly. And it goes way back up into Lake Superior Basin, advances back down, way back. And so probably that's when a lot of our landforms here in Wisconsin were forming. Oops. So I want to talk a little bit about how a glacial geologist explores the landscape and interprets the landscape. And one of those ways is by mapping what's on the ground. And the first map that we had of glacial deposits in southern Wisconsin was done by T.C. Chamberlain. He was at the university, eventually became president of the university, and Chamberlain Hall on campus is named after him and so on. But then he moved on to Beloit College and to the University of Chicago. But he was also head of the U.S. Geological Survey mapping division that covered glacial deposits. So he produced this map, and I think you can recognize just from the shape of the lake here, this is Lake Mendota. The edge of the glaciation he recognized was out here through Cross Plains. But otherwise it's a pretty simple map. He didn't have much to deal with, because he had no images, he had no air photos, he didn't even have topographic maps. So this was all done basically by riding around on horseback looking at things. And so this was, again, that was from about 1880. This one is from about 1892. And you can see there's really not much more detail. Maybe a little better shape in the lakes, but this basically derived from the same thing that Chamberlain had. And the first breakthrough was the development of topographic maps. So the first topographic maps in this area are about 1890, and then people actually had contours and they could see the shape of the landscape. This was done primarily by hand surveying. This was not, we didn't have air photos then, so it was a little bit crude, a little bit generalized, nothing like the detail we have today, but nonetheless, it was just a huge step forward. And there were two editions of the Madison Quadrangle, 1890 and 1892, basically the same. They tweaked it a little bit. But the big advance was into 1904. And this had much more intensive field work, and I think you can see that there's much more detail in the contours than there was in those last two maps. And that's just because there was enough time in between those that there was a lot more ground surveying being done. Again, no air photos, but this was letting someone who wanted to interpret the landforms in southern Wisconsin use the topographic maps to do that. And the next major step was the mapping that was done by William C. Alden. He worked for the U.S. Geological Survey. He spent a long time in southern Wisconsin, from the late 1890s until this was published in 1918. So he was almost 20 years. At first traveling by horseback, and then once the automobile started to become common, he was driving around in an automobile, and did a remarkable amount of walking, so that he is, if you read his professional paper, this is the cover of it, and it's several hundred pages thick, there's lots of things. Well, I stopped by so-and-so's farm, and he told me that he had a well that's 60 feet deep, and they had wood at the bottom. Or these kinds of, so he was obviously really connected to the people that were living on the land here and getting a lot of his information about what was in their well and so on firsthand. This is the map, one of the maps that he produced, but these are the glacial deposits. And here's Lake Winnebago up here, Horicon Marsh, here's the Madison Lakes, and the pink here is glacial till, that is material deposited directly by the glacier, and then the yellow is sand and gravel deposited by streams flowing away from the ice. And it's a remarkably detailed map. I mean, this person spent a lot of time on the ground, walking, driving slowly or riding his horse to do this kind of mapping and digging a lot of holes. So it's really good, and it's almost something that it's hard to beat even today. That's just a blow-up of it to show you the kind of detail. The dark things here are the drumlins. You can see them spreading out here from up by Beaver Dam, coming down by Madison. And again, that's the Madison Lakes. And then the outermost moraines here had already been named by Chamberlain. This is called the Johnstown Moraine, and the moraine in behind it is the Milton Moraine. And those are just ridges built out near the edge of the glacier as the glacier carries debris down and then drops it as the ice melts. So then we went from 1904 to 1959 before there was a new edition of the topographic map. And by this time, of course, there were air photos. And so this is the first map, that's a topo map that was produced by air photo interpretation and using what's called photogrammetry to put the contours on instead of surveying in the field. So it is more accurate, and basically it's the same contour interval, but it's got more detail and is almost certainly more accurate. Each of these I'm showing is of the same area over here near the town of Windsor, just so you can see the change in the detail of the map as it goes along. Well, the first air photos were 1937, 1938. And that's a black and white set of photos that's available online. If you ever want to look at it, you can go on the website for the Robinson Map Library on campus. You go on the UW website and then the Robinson Map Library. And then you can download these early air photos. They're black and white. But nonetheless, this all of a sudden let people actually see from above what was on the ground. And that was a dramatic change in interpreting, being able to interpret. And it was a dramatic change in being able to draw topographic maps, because now they could use those air photos, especially ones that were taken a little bit later, to put together more detailed maps. So the scale of the map changed. This is, I forget when this was about 1960, I think, or 62. And this is what's called a 7.5 minute quadrangle, or a 7.5 minute quadrangle, or 1 to 24,000 scale. So it's more detailed than the previous maps. At about the same time, images on a completely different scale became available. These are called Landsat images. These are satellite images. And so those allowed views of the bigger areas of landscape. You couldn't see the detail, but it allowed you to look at different wavelengths of light that were being reflected and do interpretation from that. And some things really stand out. I mean, this is Military Ridge going out toward the west, toward Dodgeville, and farther west. And then the next advance, the next step, was start to get digital images. So these are taking basically the topography, but instead of using contour lines, it's now a digital image. In other words, there are a whole bunch of points there that are tied to a coordinate of x, y, and z, meaning elevation. And this is one is available for the whole state. It's not using this new technique of LiDAR. It's basically based on interpretation of air photos done mechanically, not by an individual actually looking at the photo and making interpretation. And I should mention, you'll see this red thing on several of the maps. That's the Ice Age Trail. It just happens to be on a lot of my images. So this is a glacial map that we put together in the late 1970s, and it shows the Johnstown Moraine here, the Milton Moraine, a little bit more detail than Alden had, but basic, because we had the 7.5 minute quadrangle, so we had a little bit more detail, especially things like this expanded lake that was in here when the glacier left, called Glacial Lake Yahara, and with the topographic maps available at that time, you could do fairly detailed mapping of where that lake would have been. On the ground, you don't see the shorelines of this lake in very many places. You do up in Cherokee Marsh, you do over in the Arboretum, and you do along here down here off the Beltline. So there are a few places where you can see the shoreline. But basically, there was one big lake here all the way down to Stoughton and out to Middleton and up into Cherokee Marsh. And Alden did not portray that very well because he didn't have the elevation control. And we probably get a few more drumlins and so on. But nonetheless, that's sort of the level of mapping that you could do at that time. Yeah.
For those of us that have forgotten, could you define a drumlin?
Okay, yeah, you'll see some coming up here, but they're elongate hills that are produced at the bottom of the glacier. And basically, the glacier moves along and shapes the ground surface into those streamlined shapes, and so those are the drumlins, and we'll see some more details of those. So if we try to zoom in on that image that's produced from basically from air photography, you see it gets kind of blurry, What I'm interested in seeing here are there's some channels that were built along the edge of the glacier. This is up off Highway 12, off Ballweg Road, north of Springfield Corners. So that's what you see. And then if we add this new technique, LiDAR, this is what you see. Look at the difference. I mean, all of a sudden, we've just got a whole new scale of viewing the landscape that we didn't have before. These are what are called ice marginal channels. That is, the edge of the glacier sat here, and water came off the ice and moved first through this channel. It was actually probably first through this channel, then this channel, then this channel, and then you can see there are a few smaller ones down here. These are some forming in Alaska. So here's the edge of a glacier. This is the ice out here. And you see these channels. There's one here, one here, one here, and there's probably one forming right here. The water is probably forming running along the edge of the glacier. And then in the next slide, you'll see a photo taken a year after, or maybe it was 2 years after, and you'll see the ice has retreated, and there are more channels. Yeah, so in the last photo, the ice edge was up here, and now it's gone back to here. So ice marginal channels are hard to see, and I didn't realize those were there. When I looked at the air photos, this is what you see on the air photo. That's where the channels are. Even with what are called stereo pairs, looking at them at two together so you get some 3D, you just don't see them. Vegetation blocks them and so on. But LiDAR has the advantage of looking through the vegetation. So you can actually, well, you can adjust it different ways. You can have it look at the vegetation, or you can have it remove the vegetation and look at the actual ground surface. And that's such a huge, huge advantage, especially in a forested area, because with air photos, you don't see much in a forested area of the details. So how is it done? Well, the data are collected, and I'm no expert at this at all. I mean, all I do is interpret the images. I don't get involved in dealing with the data. But this is airborne, and it uses a combination of radar plus some light sensing device as well. And you get basically digital images that are just a scatter of data points. And they can be, then this has vegetation on it, and you can remove the vegetation and you can refine it. And that's all I'll say about that, because that's all I really know about that. But it gives us a terrific advantage in looking at these glacial features. Just to give you an idea of the status of this in Wisconsin, unfortunately, many of the surrounding states, the whole state just did it. But in Wisconsin, the state chose not to do it, and they had individual counties go off and try to raise the money to do it. So the fairly better off counties down here in southern Wisconsin have it, and all the green ones here are available to the general public. You can just go on the website and get it if you have the right software to look at it. And then the rest of these, some of the counties, the colored counties, have done it themselves or paid for it themselves. And then some counties just, I think, have decided they don't have enough money to do it. So it's not getting done. And it's really unfortunate, because this is such a good source of information. So we come back to the kind of map I could make back in the 1970s, and obviously seeing that kind of detail, you could make a much better map. And I don't know if I ever will, but I just want to, now we'll run through some examples of landforms and the kinds of things that you can see or can't see on them. So this is a topo map just out southwest of Madison. The extension of Mineral Point Road is just off the map here. Tumbledown Trail is just south. There's a golf course here. And if you look at it, you can say, well, there must be something kind of funny here because there's more forested ground, but otherwise it really isn't apparent where the moraine is. But that's the outermost moraine. That's where the Johnstown moraine is. But, gee, where is it? You can, if you look carefully, you can see, oh yeah, here, it's actually here. It's a little bit of a ridge here. And so on. But even looking at the landscape here versus here, it's hard to see a difference, isn't it? And people are always saying, well, how can you tell when you drive west from Madison where you go outside the glaciated area into the driftless area, the area that wasn't glaciated? Well, it's hard to do unless you know where it is. But then when you look at the LiDAR, look at now I'll tell you where the moraine is. The moraine goes right up here. But can you see the difference between that landscape and that? Look at the dramatic difference. You can't see that on the topographic map. So again, this is a tool that shows things that we just couldn't see before. You couldn't see it on the air photo, you can't see it on the topo map, but it stands out nicely in the radar. So it's a real boon to those of us who are interested in making maps and understanding where different glacial deposits are. I'll give you another example. So this is the glacial map on the west side of Madison. This is Black Earth Creek going down here, so Cross Plains is right here. And along here, you can actually trace the end moraine fairly well. Some of you have probably driven out Mineral Point Road and you've seen Shoveler Sink. That's where the Shoveler Sinks are. And that's the moraine, outermost moraine. And it's a considerable ridge there, so it's pretty obvious there. And you can trace it up this way. But then you kind of lose it. And then up here, there basically is no moraine that shows up on a topographic map or that you can see. So when we mapped this back in the 70s, we went back and forth and tried to see where there were rocks that had been carried by the glacier. Now, glaciers carry some rocks from a long distance away. They're called erratics. And so if in the driftless area that wasn't glaciated, there are no erratics. So at least by following the sort of the distribution of erratic boulders, we drew this line in. But now when we look at it, so there's the topographic map. That's again, that's the Table Bluff segment of the Ice Age Trail. You look at this though, and this basically it's bedrock topography. You can't see where the edge of the glacier was from there. But if we go to the LiDAR, here's that same Table Bluff segment of the Ice Age Trail. And now I'll tell you, here's the moraine. It's coming up here. You see that? Goes this way. Can you look at the difference in the landscape here versus the glaciated? It's just so distinct. It's amazing. And to think of the days that we spent back and forth trying to figure out where the heck the glacier stopped. Well, this comes out, this actually does come up here. There's a small ridge here. It follows up. You can see things that it's just amazing that we just couldn't see before. So it's a dramatic change in what you can see. Another example, let's look at some features that form back under the glacier. One of these is called a drumlin. These are these elongate hills that form beneath the glacier. And here's one from the air. Oftentimes they're not symmetrical. They're often steeper on the up glacier side than the down glacier side. So the glacier is flowing from left to right here. And here's a nice long one up by Beaver Dam. Some are more short and stubby, like this one out just off the Interstate 94 between here and Milwaukee. And here they are in northern Dane County using the LiDAR. This is Highway 151. Columbus is just off the map to the upper right here, and Sun Prairie is down here. This is the county line with Columbia County. And you can see that these features really show up. Not only the big hills, but you're seeing that in between these smaller grooves. So we're going to zoom in now on this site up here. That's a farm building right there. And we're going to zoom in on this. So you can see, I put this in so you can see this is what we mapped in the 70s. Well, we just made it all green because we couldn't see any detail. The topographic map, again, that house that you're going to see in a minute is here. What do you see? Not much. What do you see on an air photo? Here's that farm buildings again. Notice that now in the air photo you do pick up some finer lineation in the landscape. And notice also on the air photo this field, because that's going to show up in the next image. Okay, we go to that broad DEM, nothing at that scale. But look at the LiDAR image. Here's that same farmhouse building. And the glacier obviously is flowing from upper right to lower left. This is a recognizable drumlin, but look at the fine detail in between. The whole surface here is lineated that you couldn't see before. You couldn't even see them on air photos. And what's amazing is here's a fence line. That's an artificial drainage ditch. Here's the fence line. This field has been plowed going north to south. And you can see that lineation here is basically the same scale as the farmer's furrows. I mean, it's just amazing the detail that you can see there. That the plowing here has erased that fine-grained detail. So you're really getting in to look at what's reflecting what was happening at the bottom of the glacier. I mean, presumably each one of these little grooves here represents a boulder stuck in the bottom of the glacier that's being dragged along and making a groove on the bed. So we're looking at the paths of individual boulders at the bottom of the glacier. So I think that's just really dramatic. It's something that you can't even see it when you stand there. I mean, you cannot see that pattern without this. Let's skip around now and we'll look at a few more features in the next 10 minutes or so. We'll first look at what the terraces in the floodplain look like out here by Mesa Maney on the Wisconsin River Valley. This is what the LiDAR image looks like. So just again to get you located, so here's Mesa, and you'll see this point of land. We're looking at about, well actually this first slide, we're looking at this whole area, okay, out to Spring Green. So Spring Green is just off the map here, and Mesa Maney here. And what you're seeing are terraces in the Wisconsin River Valley. Terraces are old stream bed surfaces that have been abandoned as the river has cut down. So when the glacier was out at its maximum position, a wide stream carrying sand and gravel was flowing up at this level. And then as the glacier pulled back, the stream tended to cut down, and the Wisconsin River has two major terrace levels, this one and then a lower one. And then there's actually kind of an intermediate area that doesn't look like it has recent coverage of the stream. And then we have the modern floodplain that gets flooded pretty regularly when there are high flows, when there's lots of water. So we're going to zoom in and look at a few other features. Notice these fun squiggly features out here. We'll see those. Those are sand dunes. There were sand dunes out here when the glacier was here. That was bare ground, blowing sand across that surface, and probably for some time after, and some of these probably even got invigorated during the very dry times of the 1930s. But there are nicely developed sand dunes out there. You can see some cultural features. See, those are houses in Mesa Maney, or in Arena. That's Arena. And then you can see, look at the difference. Here's clearly the floodplain. Those are the channels that get occupied when the water is high. But most of those features that had been up on the terrace here, those are erased by farming and so on. But they were there. That just zooms into the sand dunes a little bit more. Again, the channels on the floodplain versus the sand dunes, and then high terrace that the channels have basically been erased, the old channels that were there. More detail right down on the floodplain now. This is called a braided stream because these channels basically form a braid across, and they occur when rivers have lots of sediment at the bottom in the bed that's being carried. All right, we're getting close. Another feature that's kind of neat to see forms in tunnels like this underneath the glacier. They're called eskers. And so here's a tunnel, and sediment, sand and gravel gets deposited in the tunnel, partly fills it, and then when the glacier's gone, it leaves behind a ridge. And these really show up nicely. This is one over in eastern Jefferson County, I think, or Waukesha County. Here's another one. Some of these the bigger ones show up on topo maps, but the small ones don't. The small ones you have to have that kind of level of detail to see. Another thing that happened along the edge of the glacier was glacial lakes. It was common for water to be dammed in those, and oftentimes there were deltas formed along the edge of the glacier, and we see really good evidence of that in several places. Now, there was a big lake here that went basically from Dane County to Waukesha County called Lake Scuppernong. And there are a number of places along the edge where we can, with this, see deltas. So here's this is a delta. This was built out into the lake. This is deeper water lake sediment. And this is the edge where the ice sat. So the glacier sat along that steep edge, water came off, and sediment was being deposited out into the lake in that delta. Well, that just doesn't show up on a topographic map. It's just too low relief to see. Another big lake we had was Glacial Lake, Wisconsin. To get you oriented, this is Wisconsin Dells, this is Mauston, the M here, and this big lake drained whenever the glacier got east of the Baraboo Hills here near Portage. And so we had this big lake basin, and we now have the present-day Wisconsin River flowing across it, as well as some tributary streams. And we'll just zoom in on those a little bit. So here's the former bed of Lake Wisconsin, has some sandstone bluffs sticking up. That's Quincy Bluff. That's Mauston, New Lisbon, High 94. And there's two, so we got the major one, which is the Wisconsin River. That has lots of coarse sediment in it, and so it's a braided stream still. It has these elongate islands going through it. The Leavenworth River, which comes into it, has a very low gradient. It has a low gradient because the whole Wisconsin River Valley is higher flowing on this lake sediment than it was before the Glacial Lake, Wisconsin was there. And so let's look at the close-ups of these now. There are sand dunes there on the bed of Glacial Lake, Wisconsin, too. Those are sand dunes. Here's what the Wisconsin River Valley looks like, and you see these elongate islands. Those are typical of braided streams. They have lots of bedload, lots of sediment at the bottom, either sand or gravel. But look at that, how different. This is called a meandering stream, and it's this sort of extreme meandering because the river is trying to take its time going downhill because it otherwise would be, it's not the river doing it, obviously. It doesn't think about it. It's just what's demanded by the flat landscape it's going over. And so these things migrate, and they have cut banks on the outside of the meanders and point bars in the middle, and these things move back and forth. And there's been considerable study getting radiocarbon dates on these. In fact, a student in geography a few years ago did her PhD on this stream system itself. So that basically brings us to the end of the presentation, and what I want to do is just give you some of these sources if you want to look at them. The USGS has all topographic maps they've ever made available online. So you can just go on there and you can download them as PDFs all the way back to the 1800s. The LiDAR images and newer air photos from Wisconsin are available from this Wisconsin View map portal, and that's the website. So I think if you just Google Wisconsin View map portal or Wisconsin View, but they have 2008, 2010, 2012 color air photos of the whole state, so you can download those. To get these LiDAR images that I'm looking at, you need to have a program that can open them and make a shaded relief, so that means a GIS program, ArcMap or something like that. And then the 1937-38 air photos are all online at the Madison Robinson Map Library at that website. And again, you can just download them. So if you're interested, you live out in the country and you want to see what it looked like in the 30s, that's the place to go to do it. Okay, so thank you.